Hi everyone, in this lecture we are going to read CSV data. First of all, let's just go to the Pandas for Data Science Essentials course. Data inputting, we're done with the getting started. Let's just move on to here. Now in here, actually the copying process is still going on because there are close to 70,000 files. So if you, by the time you are opening it, it means that it is completed. So you're going to see an artwork data CSV file. You're also going to see an artist data, and you're also going to see a collection master. We're going to take a look at this collection master later on. But let's just crack this one open, artwork data, and let's see what is the kind of CSV that we are going to work. So this is the major CSV that we'll be working on. We have all these columns like ID, acquisition, accession. We have accession number, artist role, ID, title, date, text, medium, and all of these. And these are close to 70,000. It's like 69,000 and something, 700 and something. So if I just come in here, it is 69,202. So it's close to 70,000 artworks that we have in here. I'm just going to say don't save. This is the file that we will be working most of our time in. So what I'm going to do is first in here, I'm going to create a new file. I'm going to say Python 3. There we go. Let's wait for it, and I'm going to say reading CSV data. Now, why do we need to know about this? Now, the data that we may want to analyze or visualize, it might be in different formats. But the Pandas library, it has some limitations. At the highest level, it can handle 3 types of input and output data. So whenever we're talking about inputting CSV data, so we can analyze it, we can plot it, we can transform it, we can make sense out of that data, so we can make better analytical business decisions. There are 3 types of data that we can import into Pandas, and there are 3 types of data that we can export from that. So one is text, the other one is relational databases format, and the other one is binary. Now, binary, this allows data interchanged between Pandas and, for example, Excel, software as a service, etc. For our use cases, for some of the binary formats, is whenever you want to optimize the I/O performance, or you will use the files only from within the Python script. So binary is the kind of format that we're not going to talk about. We're going to talk about the textual formats and the relational databases format. Again, binary is used whenever you want to optimize the I/O performance of your data visualization. So what do we have in text formats? We have CSV, we have JSON, and we have HTML tables. So CSV file is a comma separated file. This is a very popular format. And it is also good to know that it doesn't always have to be a comma that says comma separated. It could be another thing separated. Then we have JSON, which we're going to talk about in our next lecture, which is widely used on the web. It has a hierarchical format in which we can nest objects as opposed to flat formats like CSV. We have talked about CSV in our full stack applications as well. Now, sometimes it is useful to read data from HTML tables as well, and you're familiar with those as well. So for the purposes of this lecture, I'm going to import Pandas as PD, and I'm going to import 2 more things. I'm going to import from the path lib module. I'm going to import the path class, and I'm going to also import the OS or operating system as well. Now, after I've imported these, the next step is to import our CSV. Now, just to avoid like importing our CSV over and over and over again, what I would like to do is, after I've imported that, towards the end of this lecture, I'm going to convert it to another native Python format, which is actually easier to work with. Because this is like a very large data set, and we are not going to need all of the columns. I'm going to grab some columns from the CSV, artist, artwork data CSV, and then I'm going to convert it to another native file format, which we have not talked about yet. So now, in order to be able to read the CSV path, we need CSV data, we need to provide a path for it. That's why I'm going to use the path class. Now, keep this in mind that this path, this is very, very important. Now, the reason that I'm just going to say artwork underscore data dot CSV, I'm just going to say this is because both my Jupyter notebook as well as the CSV file, they are in the same directory. That's why I'm just going to say. Otherwise, you need to provide the name for, let's say, artwork is in another folder called data. So you are going to say data slash artwork data.csv. So you need to be very careful whenever you're selecting it. So this is going to select for us our data. Now let's read it and convert it into a pandas data frame. So I'm going to say data frame. We know how we can create a data frame. I'm just going to say data. Let's read the CSV file, and then it's going to automatically be stored within a data frame. So how can we read it? We do have a read CSV API, which is going to read it, and I'm going to pass in the CSV path. Okay, so it's going to be the CSV path, but the result, I'm just going to limit it to 5 rows only. And let's pass that, and there we go. So what we have actually gotten here is we have the ID, accession number, we have all these columns, what we only need like 8 or 9 of these columns. Now, you might have noticed something, that we do have this ID column within our CSV, but we also have this 0, 1, 2, 3 index that is available to us by this data frame that we have just created. Now, to be able to get rid of this indices and just to tell pandas, okay, I want the ID column to specify the indices, what is it that we are going to do? We are basically going to add another argument to here. So what I could do is I could just say comma index call or column, and I'm going to set it to ID. And when I run it again, now that the other extra column, it has been removed. Now let's decide which columns to use, to keep, and which columns to discard. First, I'm going to keep 2 columns, and then we are going to expand on that idea. So I'm going to say read CSV, and I'm going to say let's pass in the CSV path, and then the next one is going to be the number of rows. I'm going to set it to 5. I'm not going to manipulate this method anymore because it's going to get a little bit overcomplicated, and I want to show you like the steps that we are actually taking in order for our data set to just to make it work. So I'm just going to copy this. Before actually going forward, I'm going to put it there, and I'm going to remove this index column, and I'm going to keep that there. Let's just say df. Let me run this. There we go. We do have our indices column, and when you add that index as ID, that column is gone. Basically, I'm just trying to provide you code step by step. And next up, we are just going to go ahead and add which columns we want to use. So I'm going to say use calls. Which columns it is? Let's say we just want to use the ID, the ID and the artist. Set that. There we go. So we basically got the ID and the artist columns. Now, so far we have just 1 column data frame. Let's add some more columns just to make sure we have something that we can get more insight out of. So I'm going to say calls to use. I'm going to create this variable, and in here I'm going to pass in, let's say I want to grab the ID column, the artist column, the title of the art column, the medium of the art column, then the year column, as well as the acquisition year. What year this was acquired. Okay, this is the acquisition year. I would also like to have some dimensions, so height and width, along with the units for these dimensions. So these are the columns that I'm going to use. Then I'm going to pass it. So you can see that I'm just going to call this read CSV again. So it's going to be pd.read CSV, and in the columns, use columns, I'm just going to say, let's just pass in columns _to _use. And keep in mind, the index column is going to be the ID still. So if I say df and if I run this, so we have all the columns that we need actually from this. So, okay, I think this CSV file is, I've actually brought some changes in here, because technically this is not going to be something that, okay, the number of rows, I'm not going to limit it to 5. I'm just going to import all of the CSV file. So if I run it, I'm actually looking for this error, for this warning. The reason that you are going to see this warning is this refers to numeric columns, like width, where we might have some data which is not so useful, aka trash data. You don't need to worry about this error. We're going to tackle this in a lecture whenever we talk about numeric columns. So at the end of this lecture, what I want to do is I want to use this data in our next sections as well, in this one and next ones. But I do not want to work with like read CSV all too much. I just want to grab all the 8 columns, all these 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, all of these 9 columns, and I want to export all of this data into another format that is better and readily accessible in our Python. And that is something new that you're going to learn as well. So I'm going to say df dot, I'm going to use the toPickle format. This is going to create for us a pickle file. Pickle is a native Python format for serialization. It's a little bit of an advanced topic, but I'm just going to give you like one sentence of definition, which is going to simplify everything. Serialization is something that we use in order to write and read Python to and from our disk. All right. So whenever you want to read or write to a file on your disk, then you're going to use this pickle file. So where do we want to store it? Now in here, you could use the pathlib path class, or you could use the os module that we have imported. So I'm going to say os.path.join. This join is going to join multiple paths together. So far, what we have is we don't have within the second folder, or shall I show you here? We don't have any pickle file, right? We have this folder, the CSV file, and this IPYNB file. So within this directory, which is just a dot, what do I want to do? I want to add a file. What is the name of the file? The name of the file is data. I'm going to say dataframe.pickle. Dataframe.pickle. And if I run this, you're going to see that it is going to create a pickle file with the name of dataframe, which is just going to capitalize the D for us. So let's just run it. And if you come in here, it has run. There we go. Dataframe.pickle. It's 5.64 megabytes in size. So we have successfully created this dataframe.pickle. That's the reason that I did not give you this file, because we were going to create it ourselves. So what is inside that file? Inside that file, we have 69,201 rows and 8 columns. So all of this data that you can see here, all of that has been stored within our pickle file as well. And if you compare it to the artwork data, this is 23.7 MB, but our pickle file is just 5.6. It's like 4 times smaller than that. I know we have less columns, but it is like better. We want to constrain the data that we want to work with. We don't want to like overwork ourselves in just the first steps that we're taking to understand pandas. So this is how you can work with CSV files in pandas. See you in the next lecture.